Science has always been this incredible engine for human progress, right? From vaccines to space travel, it's how we turn the impossible into the inevitable. But what if I told you that that very engine, our most powerful tool for discovery, might be starting to sputter?
Okay, let's really get into this. Because on one hand, we have more scientists and more money for research than at any point in history. You'd think we'd be in a golden age of breakthroughs. And yet, there's this growing feeling, backed by data, that science is getting less bang for its buck. Progress seems to be slowing down, and the big disruptive discoveries are getting harder to find. So, what on earth is going on? Well, in the world of medicine, there's actually a name for this trend: Room's law. And yeah, that's literally Moore's law spelled backward, and it's just as powerful, but in the opposite direction. It shows that even with all our amazing new tech, the number of new drugs we get for every $1 billion spent on R&D has been cut in half. Every 9 years since 1950, we're spending way, way more to get less.
Now, here's the crucial point. This is not a problem with our scientists. They're as brilliant as ever. It's a problem with this system they're stuck working in, a system that has become super centralized, incredibly slow, and just full of incentives that don't always point towards great science. I mean, think about it. What do some of the world's most brilliant minds spend their time on? You'd hope it's running experiments or analyzing data, right? The reality? A huge chunk of their time is spent just writing grant applications. Some studies show scientists spend up to half of their time not in the lab, but at a desk, just trying to get the money to do the science. And that whole funding process is a massive bottleneck. It can take anywhere from 8 to 20 months just to get a yes or no. And even worse, the whole system is famously risk-averse. It tends to fund the safe, predictable projects, not the wild, ambitious moonshots that could actually lead to a real breakthrough. And on top of all that, science is facing this quiet but totally devastating crisis of reproducibility. What does that mean? It means when another lab tries to repeat an experiment from a published paper, a lot of the time, they just can't get the same results. In preclinical research, it's estimated that only a shocking 10 to 25% of studies can be reliably reproduced. Just think of all the wasted time and money that's built on such a shaky foundation. And this slide, wow, it really shows you the journey of just a single scientific finding. It's not a straight line. It goes from the author to the journal to editors to reviewers, then back again and again. It's this tangled, slow, and totally opaque process that can take years, and it just grinds the spread of knowledge to a halt. And here is the final, deeply ironic twist. After all that, the knowledge gets locked away behind these incredibly expensive paywalls. Just as this quote says, taxpayers, that's you and me, we fund the research, and then we, or the universities we support, have to turn around and pay a private company again just to read the results of the work we already paid for. It's wild. So, okay, the system is slow, it's expensive, and it's closed off. But what if there was another way? There's a movement growing, one that wants to basically rebuild the entire infrastructure of science from the ground up, using Web3 tools. And it's called Decentralized Science, or DeSci for short. I think the best way to wrap your head around this is with this analogy right here. If traditional science is like a giant, bureaucratic, slow-moving corporation, DeSci is the nimble, disruptive startup that's trying to reinvent the entire industry. And this slide really lays out the night and day differences. So instead of funding being controlled by these small secret committees, DeSci uses things called DAOs, where a global community makes decisions transparently, on-chain. Peer reviewers who normally work for free can actually get rewarded. The scientist, you, can own the intellectual property you create. And maybe most importantly, all research, including the failures, is shared, which helps fight that bias towards only publishing shiny positive results. Now, the core tech that makes all this possible is the blockchain. At its heart, it's really just a shared digital record book that no single company owns or controls. And this allows for totally verifiable, tamper-proof records of, well, everything, from who funded what to the actual experimental data itself. And a lot of these decisions are made by DAOs, a decentralized autonomous organization. It sounds complex, but just think of it as a new kind of internet-native organization. It's like a global co-op where all the members get to vote on what to do next, and the rules are all enforced by code. It's a totally new, bottom-up way to run a scientific community. So this all sounds really cool in theory, right? But is anyone actually doing it? Is it working?
Well, yeah. Let's look at a case study in a field that is just perfectly suited for this new approach, the science of longevity. Just look at this chart. Research into the basic biology of aging, the single biggest risk factor for things like cancer and Alzheimer's, it is massively underfunded compared to research on specific diseases. The National Institute on Aging gets about $400 million for this, while the National Cancer Institute gets over $7 billion. This massive funding gap makes longevity a perfect sandbox for trying out these new models.
And into this space, you have these pioneering new organizations popping up. There's BioDAO, which is a community that funds and incubates early-stage longevity research. And they're part of this whole growing ecosystem, with groups like AthenaDAO, which is focused on the criminally underfunded area of women's reproductive health, and even CryoDAO, which is funding some really out-there moonshot research in cryopreservation. Now, you might be thinking this is all just a niche corner of the internet, right? Some hobbyists. But what if I told you that one of the biggest, most traditional pharmaceutical companies in the world just invested this much, $4.1 million, directly into one of these DeSci groups?
That's right, Pfizer. The pharmaceutical giant Pfizer put that money right into BioDAO's treasury. And this is so much more than just a big check. It's a huge stamp of approval on this entirely new model for doing science. When the old guard starts funding the new guard, you know a major shift might be happening.
But let's not get ahead of ourselves. That kind of validation doesn't mean the road ahead is easy.
So, is DeSci the perfect solution to all of science's problems? Well, not so fast. While the potential is absolutely massive, the movement is still really, really young, and it's facing some serious challenges.
For one, there's this risk of what some people call a decentralized autonomous oligarchy. If just a few early members or big investors hold most of the voting power, well, then it's not really decentralized, is it? It's just a new kind of boardroom. Then there's the huge legal question mark hanging over all of it. But really, the ultimate test is results. And so far, no DeSci project has managed to get an actual drug or therapy all the way to market. The keyword there is yet. Which leaves us with the big, multi-billion-dollar question. Is this the dawn of a real scientific revolution, a paradigm shift that's going to make science more open, more efficient, and more accessible for all of us? Or is it a really bold experiment whose best ideas will just get absorbed by the old system, a system that has proven to be incredibly hard to change? At this point, only time will tell.